Okay. All right. Well, now it's just when I want to do it. But can you guys hear me okay though? Yeah. All right. All right. You can hear me okay? Good. Sorry about that, everybody. It's just gonna be one of those days. I apologize. Uh, let's just go to paint. Clearly, this thing doesn't want to be found. I'll just use paint because it seems to be less intensive. Okay. I don't know why, but it is what it is. All right. In any case, for this, we're just gonna work with it, because again, that's all I can do right now. So apologies to everyone. All right. So what we have here. So I know that the example is kind of gone, but I do remember the numbers, I believe. But I need to bring up the calculator here in order to figure this out. So I can show it to you. Telling you Windows updates screw with my computer so bad. It's so bad, man. Try and do good things, and it's like, nah, I'm gonna screw up your computer. I'm like, thanks. You're the best. Windows updates. What do you want me to do? Windows updates. I'm gonna have to do some fixing. Maybe it's telling. Maybe. Maybe it is saying something. Let's do 0.002. Yeah, 2,200. 220. Sorry. 220 to the third plus 0.03. 220 squared plus 23 times 220. Ah, come on, man. Been like that today. And then we're going to subtract by 40. What do we subtract? 4,200, right? I think so. All right. And so for that answer, after doing everything out, we get 182.4. So we get 182.4. And there we go. We got it. Yeah. So that's going to be our final answer for this problem. Let's see which brush is the best. I don't even know. Oh, that looks terrible. All right. Okay. Any questions about that? Let's check to see if that's correct. Yep. All right, that's correct. All right, questions. Sorry for the multiple oops. Okay. All right. So basically, let's look at the next section here. All right, so let's go over the next section here. I do need to get moving to the next section because I didn't expect to be delayed this long for reasons outside of my control right now until I can make it underneath my control. All right, so for the next section here, the next section is pretty much the same type of section. The only difference is that you're doing definite integrals with, say, integration by parts. Okay, so I know you guys really hated that stuff, but in the next section, they do ask you to do, say, some integration by parts with definite integrals. Okay, so it'll be done pretty much in the same kind of vein as the previous ones there. There's a couple ways to actually approach it, in all honesty, but I want to keep things as simple as possible. Let me see if they decided to go down a certain path. They may have. Yeah, they may have decided. There's two ways to actually go about this, so I'm going to do a couple of these examples here to kind of showcase how I would do this, and then we'll wrap things up here. So go to our nerdy paint tool. Okay, I see you. Okay. All right. So the first one I'm going to do here is going to be number. Let's just do number. Which one? I don't know. Actually, I'll have you guys pick. You pick them. Numbers 1 to 5. No, 1 to 4. I should say 1 to 4. Pick a number 1 to 4. And I'll do that one. 2. Alright, Lee Wen says 2. See what everybody else says. Pick a number 1 to 4, and I'll do that problem. Two? Alright, 2 it is. Let's do it. Alright, so number 2. The integral of 0 to 1 of x times the square root of 15x squared plus 1. dx. Okay, so there are going to be two ways to approach this type of problem here because we're going to be using u substitution. Now, the way I would do the integral here, let's never mind the numbers here for just a moment. I need to define a u. Now, the u I'm going to pick is the more complicated of the two functions. That's going to be 15x squared plus 1. Usually easier to take the more complicated of the two. Kind of said before. There we go. If we take du here, the derivative of this, that's going to be 30x dx. Let's go ahead and start replacing stuff in. So replacing stuff in here, what we're going to have here is we're going to have the integral here. And that's going to be the integral of the square root of u. Okay, so that'll be this part here. We have an x and a dx left over. So, okay, if we have an x and a dx left over, then we have an x and a dx here, but we have a 30 in our way, so we're going to divide by 30. We have 1/30th du equal to x dx. All right. So now what we'll do here is we have everything in terms of u, which is what we want. Take that 1/30th on the outside. since that's a constant. We can also rewrite the square root of u. Square root of u is u to the 1/2 power. U. Okay. Now, here's the part, here's what I'm going to do. I'm going to do it one way first, okay? And I'll show you we'll get the same answer if we do it one way. And then I'll show you both ways, and then you guys can determine which way you feel would be the easier of the two methods to find your final answer, okay? Because everything up to now is pretty much the same stuff. So we take the integral of u here, and that's perfectly fine. Taking the integral of u here, we'll get 1/30 times u to the 3/2. And that'll be divided by 3/2. If you take 3/2, do I take 1/30 divided by 3/2? That's gonna be, that's 1/45. So if we do that out, we get 1/45. 1/45 u to the 3/2. And then you would do the same thing you did last time here. So the same thing you did last time, you're like, okay, replace whatever you defined u as. So you would get your final answer here of your integration anyway. Sorry, not your final answer, but your answer here for integration. 1/45 15x squared plus 1 to the 3/2 power. Okay. Technically, this is what you would get here after everything is said and done. All right. Now, what you want to do next here is resize this picture. Contain it. Oh, geez. That wasn't what I wanted. That was rather disappointing. It do. Crap. All right. Well, at least it's easy to see. Question mark. Oh, that's what I did. Why Paint 3D is better besides the whole canvas. All right. Anyway. All right. Where are you? Cursor. There it is. Okay. So having that in this case here, what we can do is, if I can ever find my cursor is a nightmare to me. All right, there it is. It's hard to find. Okay. I would like it to be. All right, there. All right. Perfect. All right. So here what you can do is you can evaluate this from 0 to 1. Okay. So we haven't worked with the numbers here just yet, but this is kind of like the difference here. We can evaluate this from 0 to 1. We're going to get 1/45. All right. And you plug in 1 here to start with. Take that to the 3/2. It'll be the first one there. And then you subtract it by plugging in 0. So you get 1/45 times 15 times 0 squared plus 1. 3/2. Okay, so let's see what we get here. In this case, we get 15. You get 16 here, so we get 1/45 times 16 that. So let's figure that out on the calculator there. So we get 1/45 times 16 to the 3/2. Should be 64, I believe. That fraction. So 64/45, that's correct. We get 64/45. minus, and then this is 1/45 times 1, so this is 1 over 45. Again, you can figure out both individual parts on the calculator. Fine. So you get 63 over 45, and that certainly does reduce. 3 was that going to be 21 over 9, right? So going to be 7 over 5. Okay. We get 7 over 5. So if we do it with 0 and 1, you're going to get 7 over 5 as your final answer. Okay. So let's at least check out the answer here first. Let's see if we got the problem correct. Okay. So let's put in 7 over 5. Okay, so 7 over 5 is correct. Okay, but, now there's a but to this here. The thing is that while 7 over 5 is the correct answer here, that's not the only method to find 7 over 5. Okay, so we use the original numbers here of 0 and 1, and that's perfectly fine. However, what is the second method here? That's method 1. Let's talk about method 2. Method number 2 is going to start off at where we found the integral. Okay, so let's recall here we have u is equal to 15x squared plus 1. Okay, that's what we did there. We found the integral here was 1/45 u to the 3 halves. Okay. Now method number 2 is what we do is we change the limits of integration. Okay, so basically we change the key thing is we change the limits of integration. Okay, now exactly how do we change these limits of integration? Remember that u is equal to 15x squared plus 1? Well, what if we plugged in 0 and 1 into that formula there for u, right? What if that's what we wanted to do here in this case, right? So if we plugged in 0 and 1, that's what here we're going to plug in. Oh, come on. Plug in x is equals to x equals 1 and x equals 0 to solve for u. So we have u is equal to 15 times 1 plus 1, which equals 16. And u is equal to 15 times 0 plus 1, which is 1. So these are basically, from 1 to 16 would be our new limits of integration. So instead, with our integral being 1/45 u to the 3 halves, instead of replacing it back with 15x squared plus 1, instead of doing it from 0 to 1, we now would do it directly, and we would go directly and would say, all right, you know what, hey, you know what, I do like dealing with u. I don't want to go back to x because maybe it's a little more complicated. I can go from 1 to 16, and I can go ahead and try the same problem again. So it's like if I try at 1/16, I don't have to do these extra calculations here to get to that same result. That's essentially what this second method does. So it shortens up the work here in that regard. It's like, all right, well, let's make it a little bit easier. You say, okay, well, that's fair. And then essentially you get 1/45 16 to the 3 halves minus 1/45 1 to the 3 halves. So you've effectively shortened up the work here by changing your limits of integration and then getting the same exact answer here of 7 over 5 at the end of the day. Okay. Okay, any questions about that? May seem like a lot, but it really isn't as much as you think it is. It's just I had to first introduce two different methods to do the same thing. So, really, you're arriving at the same answer just two different ways. What I'm presenting you with, Elizabeth, is an option. Which option that you would like to go down at the end of the day. You can go ahead and replace back for what you defined as x, and then take it from the original numbers that you were given. Or you can change your limits of integration and work with u once you've found that integral, and you can go ahead and just do it directly without having to involve x again after that. So people find it one way to be easier than the other, but everybody's different. So hence why I want to give you as many options as possible. Any questions about that? All right, let's move on to the next one here. All right, let's try the next one here. I have a little bit more to add here after I do. All right, so that was your first pick there. Okay, now you get another choice here. We have 5 to number. No, that one's not. That one's. Do 5 to 9, or 5 to 10 actually. Let's do 5 to 10. That's fine. Number 5 to number 10. You guys can pick one here. Number 5 to number 10. You guys pick one and we'll do that as the next example. Number 5 to number 10, as you can see there on the screen. Number 10. Okay. You guys want to do number 10? We could do number 10. That's not a problem. Okay. Let's do it. Okay, let's go. Okay, so number 10 here, according to what we have. Alright, so the integral from 1 to 5 of x to the 8th plus 8x to the 7th, okay, divided by x to the 9th plus 9x to the 8th plus 7. Okay. Alright, let's do it. Alright, so again, I need to use substitution for this. Alright, so what am I going to define u as here? U, I'm going to define here as the higher degree polynomial, which is, again, x to the 9th plus 9x to the 8th plus 7. Now, at this stage here, in this example, you can go ahead and change your limits of integration if you would like. Okay? So, let's go ahead and see what our limits of integration is going to be. All right, so we plug in 1 in for x. If we do that, then if x equals 1, and we'll go with x equals 5. If x equals 1, we plug it in for u. We get here 1 to the 9th plus 9 times 1 to the 8th plus 7. So u here is equal to 17. Oh boy. Let's take a look at 5. Ooh. 5, this is why this method may not be the best. You have 5 to the, ooh, what is that number? That number is really big. 5 to the 9th plus 9 times 5 to the 8th plus 7. Okay. It's a pretty large number, I ain't gonna lie. Very large number. What? We're gonna do it anyway. So, here in this case, yeah, it was going to be a large number anyway. So, honestly speaking, no matter what you do in this problem, it's still going to end up to be a pretty big number. So. Alright, so if you do this on a calculator here, you're going to get u is equal to 5,468,757. 5468 757. Okay. So we have our new limits of integration here. I'm going to use the new limits of integration for this problem. From 17 to this 5.4 million number here. And you're probably saying, that seems really ludicrous to do. Well, in actuality, you're still going to run into a pretty large number no matter which way you go about it. We just take care of the work here as opposed to near the end of the problem once we go ahead and integrate for u. Now actually solving for u here, integrating here, we'll need to do a little bit more work. We need to find the integral of u here. The integral of u here is going to be 9x to the 8th plus 72x to the 7th. Okay. Now if we take a look here, let's see what we replace stuff with. Again, this stuff here gets replaced with u. So that's what we define that as. There's a dx on the out here. And we also have x to the 8th dx, but here we have x to the 8th plus 8x to the 7th dx. But here's what the nice part is that this factors out a 9. A 9 will leave you with x to the 8th plus 8x to the 7th. That's kind of what you're looking for there. So we could just divide 9 on both sides and start substituting in things. We get 1/9 du equals x to the 8th plus 8x to the 7th. So all this stuff here is going to be 1/9 du. So what do we have left over here? Let's take a look at ours. Let's take stock of what we have. We have our new limits of integration, which is 17 and this 5.4 million number. We're going to go from 17 to this 5 million. 5, 4, 6, 8, 7, 5, 7. Here we have 1 over u. And we have times 1/9 du. Oh. Okay. Well, let's go ahead and make this a little bit easier to do. I'll forego putting in the numbers here, but that's fine. I'm going to put 1/9 here, the integral of 1 over u du, which we know already that's going to be 1/9 times the natural log of the absolute value of u. So let's plug in our u values here. We're going to evaluate this from 17 to the 5.4 million. And so what we're going to get here specifically is we're going to go ahead and get 1/9 times the natural log of 5.4 million, 5468757, minus 1/9 times the natural log of 17. And this is going to be our final answer for this problem. I hope I got this right. I put, what did I put here? Oh, I put +7? Oh, damn. Why am I being an idiot today? Like 3 mistakes in one day. Let's say -7. I gotta change all the... Well, this would be if it was +7, by the way. Let's see what it would be with -7. How would that change? Doesn't change much with the rest of it. Be with -7. I accidentally... And I'm being a dum-dum today. I'm so sorry, guys. Huge dummy-dum. This doesn't change much. This, I know what this changes. This changes to 50. This changes to 50. Check that here. Oh no, that doesn't change. It changes to 43. Brud. Man. Those days. And what is this going to be? That's 1 plus 9 is 10. 1 is 7, that's... Yeah, one number changes a lot. Okay. I did dumb things. Let's just change these. My answer here would be actually... Just change these two numbers. All you gotta do is change these two numbers. Fine after. Alright, the rest of it is exactly the same. So nothing else changes. The +7 just changes the limits of integration. Okay, well, let's try it out anyway. Let's see if we got this. Glad to this problem. But okay. We're gonna test it out anyway. Okay, We got 1/9 times the natural log of 5,468,743 minus 1/9 times the natural log of 3. All right, let's see what happens here. And we got it. That is correct. All right. So despite the ludicrous numbers here, and I know that seems very silly, but you can see here doing limits of integration, at least changing them over, you can do it that way and save yourself a little bit of time, even though I got that the numbers wrong there because I put +7 instead of -7, but still, that's the way you would want to approach that particular problem. Any questions about that? Oh! Man, I was so absorbed with the problem, I totally missed what you wrote there, Lee Wen. Holy cow, that's what you, that's -7, okay. I just totally missed that. I totally missed that. Oh my gosh. If I miss something like that, guys, just spam it in the chat. Just tell me. Tell me I'm a dum-dum. It's fine. I'm a human, I make mistakes. I'm accountable for that, I got no issue with that. But, you know, just spam it in the chat. It says, no, what you're doing is wrong, okay? I'd be like, that's fine. Just tell me I'm doing something wrong. I don't mind. Remember, I'm trying to guide you guys as best as possible, so I'm very, very sorry about that. Yeah, just spam the chat. Just spam the chat if you need to and be like, hey, no, you gotta stop what you're doing. And you gotta fix it, so feel free to correct me at any time, okay, guys? At any time. All right. Yeah, that's fine. All right. Questions about that? Questions? Okay. Now, we do have a few more things that we need to discuss here really quickly. I'll be doing one more example here, and then showing. Actually, let me do that example first, and then I'm going to show off a couple things from this section that will be important here. So go ahead and do that first. So the next example that I specifically want to do here is going to be number 12. So number 12 says, one thing about number 12 that is a little different is that number 12 says find the average value of the function over some interval here. So average value is going to be a slightly different guy, and I want to showcase that. So let me go back to this. This is the handout here for 6.5. Now we'll talk about these properties here, but the average value property is down here, where we have 1 over b minus a times the integral from a to b of the function here f of x dx. So if it says, hey, can you find the average value of such and such function, you can go ahead and do that here using this little formula that you have right here. These other things that you see up top, yeah, let's talk about that right now since we're here. These other things that you see up top are just other properties here of definite integrals that you may see from time to time. Such as if you take the integral from one number to itself, like from 2 to 2 or from 3 to 3 or whatever of a function, that will invariably be equal to 0. If you reverse the numbers around, let's say you go from, instead of 1 to 3, you go from 3 to 1. If you want to do that there, it will also flip the sign, and it'll be negative. If you have a constant of a definite integral, you can do the same thing you did before. You can bring that constant out in front. If you add and subtract two functions, you can split those into two different integrals for the same limits. That's perfectly fine. And if you want to go from a to b and you want to use an intermediary number, so let's say you go from 0 to 2, you can go from 0 to 1, and you can go from 1 to 2, and you can add those two together and get the same result. Okay, so that's certainly entirely plausible here that you could do for definite integrals. But the one, like I said, I want to look at here is going to be the average value here in this case. So if you want to take a, I'll put this up on the screen here for just a second. If you want to take a small screenshot here of this, you can go ahead and take a screenshot of this, so that way you'll have that for your notes. So I'll give you guys like 15 seconds or so. Take a 15-30 seconds. Take a screenshot of this, or again, you can refer back to this video here, and then let me know once you guys got that, and then I'll move forward with this last example. Okay. Just type done in the chat once you have a screenshot of this, and then I'll move forward. Okay. Emma's got it. Okay, Lee Wen's got it. Got it. Nick, are you okay? Let me know if you're all right, Nick. Do you have the screenshot here, Nick? Of yeah, the screenshot of this up on screen. Okay, good. All right, so I'm gonna move on here. All right, I'm gonna move on, and then we're gonna do this last problem here. So, all right, so I'm gonna need to write this down. I'm gonna do the integral. The interval here is from -1 to 7. So brackets, please. Okay, so we go a and b. We go 1 over b minus a, so 1 over 7 minus -1 times the integral from -1 to 7 of 1 minus x squared. All right. Let's do this here. 1 over 7 minus -1, that's going to be 1/8. The integral here of 1 minus x squared is going to be x minus x to the third over 3. We're going to evaluate that from -1 to 7. Okay, let's figure out what that is. So here we get 1/8 times 7 minus 7 to the third over 3. Okay. It'll be this guy here first. And then minus, and then the second guy here is going to be 1/8. In parentheses here, we're going to have -1 minus -1 to the third over 3. Let's clean this up a little bit. Looks pretty ugly. Make it look nice. Here we get 1/8, and then in the first one here we get 7 minus 7 thirds. Figure out what that is. 7 to the third. So here I get, in this first one here, I get 1/8 times -322 over 3. Okay. Minus 1/8. And we have -1. So let's do -1 minus -1 to the third over 3. Okay, so here we get 2/3, or negative 2/3. All right. Let's go ahead and figure out what we have here. So we have. All right. And I'm just gonna do this straight up on the calculator here. Not gonna really have to guess here. Alright, so if you do this left side out here, you're going to get negative 161 over 12. And then here, you're going to get negative 2 over 24, so this will be negative 1 over 12. Okay. We get negative 161 over 12 plus 1 over 12 due to the sign change. That's negative 160 over 12. And I wonder what that equals. Let's do that. Lots of reducing going on. So finally we get our answer here of negative 40 over 3. Okay. And that's our final answer for that particular problem. So let's go ahead and plug that in. So hopefully we get this right. Okay, and that's correct. Negative 40 over 3. Nice. All right, ended off on a good note, so that's good. All right. Any questions? Any questions about that? No. All right. Emma, no. Elizabeth, Nick, any questions, you guys? No? Okay. All right. Nick, any questions, my good friend? Okay, that's fine. That's fair, of course. All right. Well, I apologize for the restarts here. I may know what's going on here. I'm contemplating exactly what's going on, but I'll have to do some things on my end here and get things hopefully sorted. All right. In the meantime, though, I want to thank everybody for coming on out here to the stream. I apologize for the stop. Like I said, I apologize for the stop and starts here. That's not intentional, but it is what it is, I guess. Okay, but thank you guys very, very much here. I appreciate it. All right. I will be back here on Monday. I wish everybody a very wonderful and happy weekend. I will be working on the last exam here and the final exam this weekend, so it's going to be doing a lot of work this weekend for you guys. That should be posted here either should hopefully be posted by Saturday. So Saturday is really what I'm kind of aiming for there. Okay, guys. Thank you so much. Thank you for being patient with me. I really appreciate it. And I will see you all on Monday, same time, same place. All right? Everyone, have yourself a very wonderful weekend. And as always, stay safe, stay healthy, but most importantly, stay sane, everybody. All right? Have a great one, everyone. Take care of yourselves. All right? Indeed. All right. Have a great one. We'll see you later. Stay sane. I'll try. I'm going to try this weekend. It's going to be rough. All right. Next time. Yeah, no problem. No problem, Elizabeth. All right. Thank you. Thank you. Take care, everybody. Bye. Bye, everybody.